Hello everyone, welcome to a webinar about microservices in Node.js. My name is Adam Polak, I'm a head of Node.js at TSH, a software company specialized in web and mobile applications. At some point we decided to share some of our experience with a community, and so today one of our lead developers is going to talk about microservices architecture. Feel free to check us on tsh.io. Also, if you are a Node.js developer from Poland, then check our career page for some remote work possibilities. What's more, I strongly encourage you to ask any question during this webinar. You can do so using a specialized tab called Questions on your right, or simply by using chat. Together with Mariusz, we are going to answer as many questions as possible. So without further delay, let's start the presentation.
So hello everyone, I'm glad there are so many of you. Today I'd like to tell you more about microservices in Node.js. During last months, we've been developing quite a big application using microservices, and we gained a lot of experience in this particular topic, and we would like to share our knowledge with you. Can you see the presentation? Yeah. Okay, there's a presentation. So a few words about me. I'm a lead developer in the software house. If you would like to contact me, there are some links and my email. And I will be talking about monorepositories we are using in our current project. Then I'd like to tell you something about contracts, especially about gRPC and why we are using code generation in our project. There will be some words about Docker usage. Then I'd like to introduce you some of the patterns we are using regarding communication between services, data storage, and some security stuff. And last but not least, some words about logging, tracing, and how we are testing our project using Docker. So during my career, I've seen many projects, and typically most of them had quite typical, quite generic structure. By typical, I mean applications which are divided into two parts. One part which is our backend, our API, and the second part which is front-end, usually single-page application. And in that approach, usually every app is sits in its own repository. There are some developers developing it, knowing that particular technology. We can use Node.js and backend, React or Angular frontend, but with time, these apps usually gets larger and larger, and sometimes it happens that we have quite monolithic applications, and we know that monolithic applications are quite difficult to understand, difficult to modify. Development slows down over time, and also modularity breaks down over time. So this is actually a good moment to introduce microservices. And I'd like to focus on the backend part today. So we would like to divide that application into microservices. And some known facts about microservices. So as we know, this is some common knowledge we can find surfing the internet. So they are small, easy to understand, and easy to test applications. And thanks to that, we can do quite frequent deployments of these applications, and they can be developed in quite independent teams. And moreover, every application, every microservice can use different technology, which is best for some specific purposes. For example, we can have Node.js for some security stuff, or we can have some Python microservice for other stuff to do. And yeah, so let's split that monolithic backend I showed you previously into microservices. So we are leaving SPA as it was, and now we are dividing our backend into many different microservices, and just following these definitions about microservices, we have separate repositories for each of the microservice. We also decide that we are developing these microservices in various technologies best for specific purposes, and we need to actually put a lot of developers into these microservices, each one knowing different technology. And it looks fine, but there are some problems with it. The main problem is that it is quite hard to move developers between projects, because some of them know only a few technologies, and they actually cannot, for example, start doing project in another technology. And but the advantage is that we can actually have best possible tech for each use case that we have. Actually, it might be a good approach for Netflix. For their scale, it is actually achievable because they have money for it. They have offices all around the world, and usually people working in all of these offices actually don't know one each other. But actually in the TSH, we don't have projects of that scale, and that's why we wanted to actually adjust that approach for our specific use case. So here in TSH, we are working under one roof in one office, usually very close one to each other. So we decided that we would like to change that approach, and because we actually experienced a lot of disadvantages of that approach with multiple repositories. We've been there, and we needed to actually adapt to something else. So we decided that we would introduce monorepositories for per technology stacks in our project. So let's say we have our Node.js tech stack, and we are actually creating some of the microservices in that particular technology. The advantage is that we can actually move developers between those microservices. If we need to do something in another technology, then we can introduce another technology stack and actually put it into another repository and assign some developers to it. We also create some common libraries that we can use across all of the microservices which use one particular technology. So yeah, there are a lot of pros of that approach. It's easier to develop if you have one repository. Let's say you need to introduce a new feature for your business, and instead of making 6 pull requests, you just make one. It's quite faster and easier for all of the people in the project. It's easier to synchronize code actually, and to extract some shared code. And with that approach, we can have some similar continuous integration, continuous deployment processes for it. Yeah, as I said, it's quite easier to move people between projects, and having one tech stack actually gives us opportunity to get some security updates more quickly. We don't need to update every possible tech stack at one time. And yeah, there are some cons, of course. One of the con is that we have some larger code base because we need to put all of the microservices in one monorepository. But if we, of course, keep boundaries, then it's fine. But of course, we need to be aware of that, and we need to put some effort into it to keep those boundaries. Okay, so with that approach, you might think, how long might it take to set up a new service? Actually, in our current scenario, current solution, it just takes a few seconds for us. So we have something called code generation. We wrote a code generator which scaffolds projects for us. And to achieve that, you actually need to have some similar structure in all of your microservices. Having that similar structure and having that tool which generates code for you gives you the opportunity to actually use that tool across all of your microservices. And with that, thanks to that, you can focus on business logic instead of writing boring boilerplate. And moreover, every service needs a contract. So there are a lot of various options for that. For example, you can use API, Swagger, RAM. Our choice for our current project is to use gRPC. gRPC is a tool from Google. It's a highly performant open source framework for RPC, which is remote procedure call. And with that framework, you can define your contracts using protocol buffers. It's kind of language and serialization toolset. It's a good tool for communication between microservices, but it's not for everything. For example, we are not using it for file uploads and something like that. So yeah, with gRPC, we can define contracts which looks similarly to this. In PROTO files, you define your services, your methods using special syntax. And in each method, you define proper typings for requests and responses. And yeah, having those PROTO files, having those contracts, it allows us to actually generate even more code because our code generator tools can produce TypeScript types based on these contracts. So yeah, it actually gives you even more time to focus on your business code instead of doing some boilerplating. And yeah, moreover, in our development, we are using Docker and Docker Compose a lot, but we also went through many different approaches with it. So during our work, we achieved some good configuration of it. So here are our key choices when we are using Docker. So first of all, we use one Docker file per our monorepository, and thanks to that, we can actually keep it up to date and understand what's under the hood. So it's actually, for our case, it's quite better than having a lot of different Docker files across the app. Moreover, we are using one image per environment. So for example, having that Docker file, we can define one image per production or per development purposes. And to achieve that, we use multi-stage builds. This is something I'll show you soon. And to actually run many different microservices, having that one Docker image, we need to use something called entry points of Docker images. Yeah, and Dockerfile, which gives us that opportunity, might look something like this. Actually, this is not quite important. The code inside this slide is not quite important right now. I just wanted to tell you the idea of what we are doing. So having that one Docker file with multiple stages, we can actually, as you can see, produce development images and then production images based on those development with some more commands executed against those images. And having that image, then we are using our Docker Compose. And as you can see, in this particular example, we are using the same image, but with different commands, different entry points, so that allows us to run various microservices. Okay, a lot of people are asking what should they do when they have monolithic application. How can they start? Yeah, we'll get to that soon. Maybe we can answer some questions right now. Okay, Kacper is asking if you are using TypeScript, which gives you types and features from objective languages, why don't you switch for another language technology? So actually, a lot of people in our company have background in JavaScript, so it's quite a good migration from JavaScript to TypeScript. Because it's still JavaScript under the hood, and it's quite important to have people knowing that particular technology. So yeah, maybe it would be good to use also microservices in other technologies, but we have some very experienced people in JS here. Okay, another question from Michael. In regard to simple CI/CD processes with a monorepo, how do you handle the deduplication of build, deploy runs? For example, there are two apps, A and B, where the build of A takes 10 minutes and B takes a few seconds. Now only B is changed over and over again. How do you prevent running A all the time? Actually, in our scenario, we are redeploying the whole stuff. It's maybe not the typical use case, because most of the cases are where we are deploying separate microservices. We are redeploying the whole tech stack. There are around 15 microservices, but it's redeploying them is quite fast for our case. Yeah. Okay, so maybe let's get back to the presentation. So I told you that we would like to break monolithic up into some smaller microservices. So this is where we start. We had our monolithic application and our SPA application. And the first thing we should try to do is to introduce API gateway. API gateway is one of the patterns we use in microservices, and it's usually another microservice responsible for routing the traffic to our system. And placing that API gateway in front of our monolithic applications and in front of our some brand new services gives us opportunity to route traffic to those new services if necessary, and to the old monolithic applications if necessary, if there are some implementations of business logic. And actually, it's good to know that they can coexist, those monolithic applications and these services, as long as we develop new things, and eventually we have some only microservice-based application, so we can get rid of our monolithic application. But of course, it's not as simple as it seems to be. So let's take a closer look at the API gateway pattern, which is quite interesting and actually quite a first thing to do in our project. So with API gateway, this should be actually the only entry point to our whole system. We shouldn't communicate to other services directly. So clients should only send messages to our API gateway. And this has a lot of advantages, that particular approach. So yeah, thanks to that, we can have some common message handling in one place, some security stuff in one place, refreshing access token in one place, and a lot of others. And of course, it's much safer to have it in one place, and we actually don't need to duplicate that code in other services as well. So if we would like to communicate with our system through gateway, then we should define some common message format, which our API gateway can understand. So in that message format, we are using service name, service operation. So the API gateway knows where to send that message. We, of course, send some payload, which is used by external service. And we can add a few more things like access tokens and so on. And if the message has a proper format, then the API gateway can handle that request properly. So let's say each time it gets a message, it looks for a proper client, which gives opportunity to connect to that particular microservice, and then it sends that request to that service, then sends back the response message to the client. Yeah, and API gateway can understand, can know the other microservices using some, static list of clients, or even can use some more sophisticated approaches like service discovery. So each time some service gets up, API gateway knows that and can send requests there. And it's quite important that API gateway should not contain business logic. It should be in other services, not here, because simply API gateway is not responsible for business processes. And to handle security, let's say we are sending access tokens to gateway, then we can, for example, communicate with other service, in this example, a messaging service. But if we are not sending access tokens, then we can, close the traffic in API gateway, and even we don't need to communicate with messaging service. Okay, so we send message to our system. So let's dig deeper and let's find out how these services can communicate. So there are different approaches. One of it is remote procedure invocation, also known as a remote procedure call. For that purpose, we can use, for example, gRPC. We can use good old HTTP or even socket.io. We are using mostly gRPC, and to communicate between client and gateway, we are using WebSockets. Another possibility is to use message broker. So message broker is a quite different approach in which our services are communicating using that message broker. So they are sending messages there and getting messages from there. And it has some advantages because they are not coupled. and those messages sent to message broker can be buffered. So if, for example, second service is not working properly and then will get up eventually, then that message can be obtained later. And it's also good to know that these approaches, for example, message broker and RPI, can coexist. We can use both of them in our system. It depends on what we are actually using, what kind of processes we have, so we can get best possible approach to our needs. Okay, and so our microservices can communicate freely in our system, and it eventually get to that point when we need to store some data. And as with actually everything in microservices, there are different approaches. And one of the approaches is to use database per service. In that particular approach, each service has its own database, which is only available to this particular service. And yeah, there are some pros to it. For example, it scales more easily, but it's quite harder to write queries for it, and it's harder to keep data consistency. Because, for example, when something goes wrong to, let's say, service 2, and there will be data in local database for service 1, and there will not be data for local database for service 2, then we need to handle that situation somehow, and it's not that easy. So the other approach is to use shared database. We are simply using one database for more than one service, and it's harder to scale, but on the other hand, it's easier to write queries and easier to keep data consistency. And in this project, we are actually using a shared database, but with something we call live queries. So this is actually not the typical approach, because live queries gives us opportunity to query for data one time, and then to every time data changes in our database, it pushes updates back to the clients. And with that approach, we can actually create some fast real-time applications. So let's walk through how it might look like. So let's say the first client is making a request to our system, and in that request it is specified that he wants to subscribe to data, let's say to a table user, and he wants to order the responses by salary. And inside our system, we are creating a subscription in our data service, and for that purpose, we can use RxJS. Yes, we are using that. And our choice might be a RefingDB, because it supports live queries. We are actually using something else, some custom-made solution, but RefingDB might be good as well. So in this scenario, the subscription was made, and now the other client, let's say client 2, is making another request with a command to our system, and in that particular command, he adds a user, John Doe, with some salary. So it goes through all of our microservices in our system, especially through our data service, and then once the user was added to our system, the first client gets data flow with all the updates that were made to the system. So there is that John Doe added with his salary. And this approach is also it follows the CQRS pattern, which is command query responsibility segregation. And thanks to that approach, we actually don't need to use API composition pattern so much. But it actually comes with some disadvantages, or I might say with some technical problems to solve. So it might be quite difficult to, let's say, restrict access to some data. So let's say our user cannot see salary field. How to handle that? So we actually are using ACL, which is access control list, and its specific implementation ABAC, which is attribute-based access control, where we can control in quite granular way who has access to what kind of resource. And we implemented some controlling of streams, which supports security as well. So going back to that approach, to that example, so let's say the first client gets that data flow constantly, but now we are also checking access control list for that user in our data service. Of course, it might be checked in another service. It should be done in security, but yeah, that job can be delegated from data service to another one. And then knowing what this particular user can access, we can filter that data in the fly and return that filtered data to the client. Okay, so maybe we can get back to questions. Anthony is asking, what kind of scale would you need to switch to multiple databases? So that's quite of I would say maybe it's not about scale at this particular point, but maybe you should actually think of your approach. It really depends. It's quite hard question without any examples, I'd say. We are using around 15 microservices in our current solution, and that shared database, if it's scaled up accordingly to those services, it actually suits our needs very well. But I think that when you would have, let's say, hundreds of microservices, yeah, then it would be very problematic to maybe have that one shared database. So, you know, in very big solutions, I'd say, for example, Netflix scale, then they are definitely not using one shared database. But yeah, in some smaller scenarios, smaller systems, you can actually try to use that. Okay, Roman is asking, do you use GraphQL in your projects? So we are not using GraphQL, but this is quite a nice question, because as you show on my slides, we are using some specific language, and with that we can subscribe to some data changes. So let's say we created some queries, and we subscribed to let's say data changes in users table, but we can as well subscribe to some other kind of changes. And yeah, you might think of it like of a GraphQL, But yeah, this is something else actually. But I strongly encourage you to use GraphQL because it's quite nice technology. Okay, Saso is asking, do you use Kubernetes in your stack as well? Yes, we are using Kubernetes in our stack. So if you have a Docker-based application, then orchestrating it with Kubernetes is a good choice. Okay, Aurelian is asking, how do you define the boundaries of your services? Boundaries, so we have them defined in separate directories, but you might also ask about boundaries of maybe logic boundaries. So we have services such as for handling security, for handling our API gateway requests, services for data management, services for users management, and so on. So it's quite specific problem to solve, to find boundaries. It really depends on your business requirements, but yes, we had something like this. Okay, so let's get back to the presentation. I was telling you about data consistency and problems that might occur when you have multiple microservices and with local databases. So we can actually try to solve that using SAGA pattern. And with SAGA pattern, this is actually kind of another microservice or just code which coordinates a sequence of some local transactions across multiple microservices. And with each that transaction, actually there comes a data update. So database update actually. There are some local transactions in that databases. And if the transaction fails, then SAGA should handle that accordingly, executing some kind of a rollback for all the related microservices to keep data consistency. So I'll show you that using an example. So let's say we have 4 microservices, and we would like to create to execute some more complex command in our system. So we are communicating service 1 with our SAGA and trying to execute that operation. So our SAGA knows how to handle that. So it just sends requests to another services. So let's say we are now executing first operation, which results in data changed in service second, and it was successful. Then we are executing even more operations on another service. It also results with data changed in service 3, but then we've got some error on service 4, and SAGA was informed about that, and it should actually handle that situation somehow, because as you can see right now, we've got data inconsistency in our system. There are 2 databases with changed data and 1 database with nothing, and so it shouldn't be like that, because it might create even more problems in future. So SAGA tries to solve that problem, and it just sends requests to service 2 and service 3, telling them to actually roll back these changes. And if it's successful, then SAGA can tell the service 1 that the operation was unsuccessful, but at least we have no data inconsistency in the system. So we are using SAGAs in our system, and we are using something called workflows to handle some complex business processes. I'll show you that using an example with 2FA authentication. Yeah. So with workflows, we define kind of state machines, which are telling us what kind of states we can have in the system and what kind of transitions might occur between those states. So this is just kind of a graph with nodes and arrows. And actually, using that state machine, we can also describe some rollbacks if we need to go back from one state to the previous one. And this graph can be written as code using that library from NPM called JavaScript state machine. And having that state machine defined, let's go through our login phase, which is implemented in our workflow service. So first of all, when we would like to log in, we are, of course, communicating with our security client because it is its responsibility to authenticate user, and we get our token from it. Then we are initializing our flow, and we are trying to transit to the first step of that flow, to login. If it fails, then actually we can inform user that there was something wrong. But if not, then we can go further, and we can try to generate 2FA code for him, and also send him that code in email. And once it's sent, we can transit to another state of our state machine. Before finishing that login phase, we need to store that process somehow, because later then we would need to recreate that state machine when the user tries to actually check our 2FA code. So last but not least, we are sending back that process ID to the user. So when the user tries to use that link from the email, he sends us his process ID, then we know that how to actually recreate that state machine and go for the process. So the next phase after the login phase is phase of 2FA code confirmation. So first of all, we are trying to recreate our process and recreate our login flow and our state machine from that process ID sent to us. And if we actually can recreate it correctly, then we are trying to confirm that code user sent to us, of course, using security client, because that's his responsibility. And if it's successful, then we can transit to another state. If not, we are just sending user some validation error or something like that. Okay, but it usually happens that something goes wrong, even if we have very fancy tools, very fancy tests. There might be always some kind of very specific situation when something goes wrong. And usually for that purposes, we are using logging. But in microservice-based applications, when there are a lot of microservices and they are communicating asynchronously, it might not be a good or a good solution actually, because it wouldn't tell us what happened when and in what specific sequence of operations. So for that, we are using tracing. And tracing is a kind of technique that we can use in distributed systems to give more insight into code execution across multiple services. And if with tracing, we actually know what, where, and when happened. So system having that tracing enabled should have kind of tracing server which gets all of the information required about multiple and various operations in other services. So if the client sends a request to the system, then before it goes to another microservice, the proper service, in this case API gateway, should communicate with tracing server and send their information about what was executed and with all the required parameters. But then, before the API gateway communicates with another service, let's say service 1, it needs to send some kind of tracing ID, which later then can be used to, find a correlation between those operations. So we are executing some even more operations, and we are sending that tracing ID all across the microservices in our system. And of course, all of these microservices are sending data to our tracing server. We are using a ready-made solution for it, which is JAEGER. It is an implementation of open tracing standard used for distributed tracing. And JAEGER was implemented by Uber Technologies. They are using it on a very much larger scale, but it suits our needs as well. And JAEGER also provides quite useful user interface. First of all, it allows you to find all the traces in your system. And when you click a particular trace, you can find details about it. So you can see the services which were used in a particular request, and you can check how much time it took to process messages, and each code execution in a particular microservice is called a span. So you can even check that span details. And in this span, you can see a lot of different tags. And actually, this is a place where you put data. There might be any type of data you would like, because it is just for your purpose to find something useful there, and you can even filter those traces and spans by those tags. So we are storing their types of messages, services we would like to communicate with, operations and payloads. So later then we can find everything we need. So adding it to the project is quite easy if we are using Docker, because on Docker Hub we can get a ready-made image for JAEGER server. And once we set it up in our Docker Compose, then we actually need to add some implementations to our microservices. So first of all, if we would like to trace some code, we need to, of course, initialize tracer, but it can be done once per service setup. And later then, we need to create a span. And between creation and finishing of the span, we put some code we would like to trace. And we can also add those tags that will help us find then those traces and spans in JAEGER UI. And if we have some code traced, then we need to send tracing ID to another service. So there are, of course, ready-made methods for it. There's that inject method, which can get us proper tracing ID. But then we need to somehow send that tracing ID to another service. And it really depends on what we used to communicate between services. If we are using HTTP, we can send those tracing ID with headers. If we are using gRPC, we need to change our contracts accordingly to it. It's just our choice. And later then, in another service, we need to somehow receive that tracing ID and parse it. So once it's parsed, of course, still built-in method in our JAEGER tracing. Once we obtain that tracing ID, we can create another span, so we can trace code in that second service, but then we need to define the parent of that particular trace to just make a correlation between those traces. Okay, tracing can actually give us a lot of information about what's wrong in our system, but it's actually better idea to write some tests and to avoid that problematic situations if we can. We are actually thinking that testing pyramid is best for every case scenario in the world, but then we realized that it might not be as well for microservice-based applications. So then we just realized there is something called testing trophy. And yeah, testing pyramid is on the left, and testing trophy is that shape on the right. In testing trophy, we put less effort on unit testing and more effort on integration tests. And this is quite important in microservice-based applications because unit tests actually can't guarantee that your communication between microservices is working. You are just testing microservices in isolation. And with integration tests, you can check and verify if they can communicate properly. And this is a very important thing to do, and it actually gives you 100% information that it just works as it should be. Of course, we are also using some static code analysis, which helps us to prevent some very nasty bugs. So we are using Prettier, TS-lint, and SonarQube for it. We are also writing some end-to-end tests, but not so many, because as you know, they are quite slow. So we are actually putting most effort on integration tests. And for end-to-end tooling, you can use Kakunin or Puppeteer. Kakunin is our open source projects created in TSH. You can find it on GitHub, and it uses Protector and Gherkin under the hood. You can test solutions on various browsers as well. With Puppeteer, it's quite a low-level tool. It uses Chrome DevTools API under the hood. You cannot verify all the possible browsers, but it's quite a good solution for some smaller scenarios. So I mentioned in the agenda that we are using Docker in tests, and yeah, it gives us a lot of different advantages. Actually, to start using integration tests in Docker, we need to define in Docker Compose another kind of service which executes those tests. And this is quite important that before we execute our tests, we need to check if the whole infrastructure is up and running. And we wrote some custom shell scripts waiting for particular services and ports to be opened. And once everything is ready, we can run those tests. And one more important thing is that we actually control our infrastructure in tests. So, for example, we can stop a service, check some tests, and then run that service again. And it actually gives us a lot of various approaches to test things in our system. So to start doing that, first of all, we need to do something called Docker socket forwarding. We need to forward Docker socket from host to our service in Docker Compose, so that later then in that service we have access to various Docker commands. So we created some utility functions, and with those functions we can pause or unpause various containers, Docker containers, using simply shell exec. And yeah, with those utility functions we can write quite sophisticated tests. For example, we would like to test how the authentication looks like in our system when we communicate through API gateway, but our service with security is done. So first of all, we are pausing our container responsible for security. Then we are sending a proper message to the system with valid credentials. And later we decide that it is actually a good situation if it times out in this particular example, and if it just doesn't crash. Yeah, and once the test passes, we actually can unpause our security service because it might be used by other tests. And it is quite important to test things like that, because in microservice-based applications, there might be some very nasty problems when some services are not responding, other services might not be prepared for it, and they might just crash. With such tests, we can verify that situation and be sure that everything is working correctly. Yeah, so testing negative paths is very important for us. And yeah, actually it was everything I wanted to tell you about our different experiences in microservices. I'll just sum it up. So try to use monorepositories, but of course, before using that, you just verify if it suits your needs, if it's good for your organizational structure or your business project. Yeah, if you can just create some generators which can generate some boilerplate code for you. If you find some places in your system when there are some similar structures, then you shouldn't be writing that every time you add some new service. Try to obtain some good tooling for it. And yeah, use some kind of a contracts that doesn't need to be exactly gRPC, but having contracts is a good idea to start with. Yeah, use Docker if you know how to, because yeah, at the beginning we had actually also some problems with it, but we solved them. So if you know how to use it properly, it gives you a lot of possibilities. For example, it gives you a possibility to test your infrastructure and control that infrastructure and test. Of course, you should get familiar with various patterns, because it helps a lot to start with microservices. It's good to start with API gateway, because it is the first, actually probably first service you will start writing. Yeah, and moreover, try to trace traffic in your code. And of course, if monitoring and tracing is not everything you can do, you can also test things in your application. So try to test negative paths, write as much integration tests as you can. You just can't follow the testing trophy as we are following. It's also worth knowing some other things related to microservices, because I haven't introduced you to everything that can be used in microservices. So circuit breakers, mechanism used to close communication between microservices. If there are some services down, it's good to know how to use them and introduce them to our applications. Some health checking and service discovery that can be used, for example, in API gateway service responsible for communication with other services. Service discovery is a good technique to actually register and unregister dynamically services in our system. So it's good to know some different deployment patterns, not only deployment patterns related to Kubernetes, but we can also use, for example, serverless approach with some functions as a service functions, and we can use for that purpose, for example, AWS Lambdas or Google functions as well. It's good to know how to handle load balancing, scaling of services, of databases, how it's related, how to do it properly, how to introduce sticky sessions in your applications. Yeah, last but not least, how to decompose services based on our current business requirements, how to use service-based architecture. Yeah, and actually, it's everything I wanted to tell you. Maybe we can get back to questions and answer some of the questions. Okay, Towns is asking, how do you handle large data requests between microservices for performance? So we can actually split that very large request into different smaller requests. I'm thinking of maybe some, if you say about big requests, maybe there might be an example with file uploading or something like that. So we can then chunk it into some smaller requests or something like that to be able to process that data more in a faster way. Yeah. Okay. Do we have some? Okay, so I think that's this is actually everything. So thank you for participation in this webinar, and I strongly encourage you to take a look at our newsletter. We have created one for devs and tech leaders. There will be some curated list of some articles, news, and some open source projects which we find interesting. So if you'd like to have a portion of a very good content, then just sign up to our newsletter. So thank you for today, and hopefully maybe we can see each other on another webinar in the future. So bye.